bit about mathematical modeling. And so before we get to our activity today, we're going to define what triangular numbers and what rectangular numbers are. So first of all, triangular numbers are numbers that can be arranged in a triangular pattern of dots. And so if you notice, I've got each of the first 7 arrangements. So when we're referring to the triangular numbers, we're actually referring to the numbers that are at the top. So we're referring to the 1, the 3, the 6, the 10, the 15, the 21, and the 28. And this is real similar to something that you had on your quiz yesterday. Okay, that one, that what, 1, 3, blank, 10? Okay, remember that one?
Oh, yeah.
You know you had to draw the picture? Okay, and so then how do you get them? You add what to 1 to get 3? 2. Then what do you add to 3? 3. So that's the triangular numbers, okay? And that's how they're formed. That's how that sequence is created. Now the rectangular numbers, on the other hand, are numbers that can be arranged in a rectangular pattern of dots. So notice here we start with the 2. Then our next one is a 6. Then our next one is a, try again,
12.
12. Then our next one is a
20.
20. So let's see, what are we adding here? 4,
6,
8. So what would the next one be?
30.
30. Okay, because you're adding 4, 6, 8, 10. Okay, next one will be 12. So those are some things just to kind of file away to memory. Those are what are known as the triangular numbers and the rectangular numbers. And if you forgot what they are, you could draw them out really quick. It's not going to be that hard. So with that in mind, we have an activity on page 108 in your book. So I need you to turn to page 108. Now what I'm going to do is put some groups together. Okay? So Lane, I'm actually going to ask you to join Austin, or Austin, you can join Lane. In fact, I also want you to come over here because that'll work better with the groups.
I need my book.
Okay? If Lane's got his, you'll be fine. Okay? So on page 108, I want, okay, you two groups to work together. I want you two groups to work together, you two together, and you two together. Okay, now notice what this says. It says each of the 30 people at a party shook hands with everyone else. How many handshakes were there all together? Act out this problem with members of your group. Collect data for parties of 1, 2, 3, and 4 people. Record your results in the table. When you get done as a collective group, I want you to look for a pattern and then generalize it so that you know how many are in 30. Okay, so you all have groups of 4. So I want you to go through, complete that. So if you have to, you could act it out. Okay? And so go ahead, fill the table in. I'm going to give you a few minutes and then we're going to come back together and talk. What?
You guys should
That's fine.
come on down.
Yep. So, hey. Hey.
It's easier for all around.
Do it speed roll.
I'm guessing it's 29.
Alright. 4, 1, 2.
Wait, so there's to find the number of handshakes, it must be 29 times 30.
True.
To find the number of handshakes, it must be 29 times 30. Okay.
Yeah, we gotta do 2. We gotta do 3 to fight first. So 3 would be 4 would be 12. Well,
3.
No,
That's true.
You
Now
would
there's
count double.
now there's
4,
2,
1,
2,
3,
4, yeah, 1, 2,
How do you get a third?
Wait, what do you mean?
So
If
like,
you have a group of 4 people, they should.
Okay, let's just do it. So I'll go first. 1, 2.
No, we'll get, it's 30.
no, we'll do the 4 first.
Okay, so let's do 3. 1, 2.
3. There's 3
Yeah.
possibilities.
Looks like you
It's
just
true.
did 3 inches.
So 3 would be 3. So 4. I'll go first. 1, 2, 3. Because you also can't play two.
Six.
No, you've already shook them in.
No, 7,
Six.
6.
You guys done?
Yep.
So, four.
You even know how many for 30?
No, we don't.
Yeah.
Oh, we do?
Oh, yeah, we do.
Yeah, we do. So,
Serious?
add one, add two.
I don't think it's.
Yeah, because she. Here's 1.
2, 3,
Yes.
4, 5.
But on the chart it says one here, than two. Everybody shakes everybody. Yeah.
So,
There's 30 people. So it just goes up 1, 2, 3, 4, 5, 6.
It's like
29
previous number.
3 people you get.
Then the other people shake 2.
2.
3 plus
Exactly.
6.
Like every person has to shake 29 minutes.
Plus 2.
Well, I can't shake.
Somebody do that. It's gonna be less than 100.
Yeah, see.
In between 8 and 9. 870.
I shake my hand. Yes. No, 7 probably.
We're attempting.
Let's try with 5.
9 get 8.
5.
So 30 you get 29.
9.
So we're
No,
actually trying to figure out
You
if
said
one,
that they
4 of
did
us
it.
run party with 26.
It's a big number. So what up with that?
It's between 0 and 900.
And all four of us shake our ways.
We could draw a third gone and connect the vertices.
Okay, I'm gonna give you about a minute to finish up.
So, 30.
Draw a third
Blue
gone.
red.
But what was here?
Right. Right. That's weird.
So if I'm not doing it, I'm gonna shake 29. And you're gonna shake 26.
No,
Is that shake
Kelly, we did it.
The next person would be 12.
Yeah.
This is negative.
Geez, Jeff.
Okay.
You're three people. You can shake his hand.
No,
Shake
no.
his hand.
You can't shake Tyler's hand.
So
So
there's
it'd be
3
29,
Shake
it'd be
that.
29, 28.
I already shook his hand.
It's all good until you do it right time.
No, I shook his. So he shook 30.
Yes. One.
until we got to like half the people who didn't ever want to shake. It's very difficult. So that's like, we know how to do it in theory, but Kelsey, you're gonna break it again. Already broken. So it's so you still take care of your stuff.
She, Courtney so through her hand.
All right, let's go ahead and come back together.
It's like went through her fingers.
So let's go ahead and talk about what you found out from your little experiment. How many handshakes did 3 people give?
3.
3. Okay, so 3. I'm supposed to have a 3 underneath here. For some reason, it's not coming out. So anyway, 3. All right, how many did 4 give you?
6.
Did anybody get number 30? I'll tell you this much, it's more than 400.
Yeah.
400.
We got
435.
435.
I
I was right, guys.
Now, I heard an interesting way to find that, and what did you guys say you needed to do? Because you were right,
30 plus 29.
not 30.
Well,
Yeah, I started
29.
29.
Because each time somebody's already shaken the previous person's hand, so each time there's less one
Or you
shake.
could draw a third, or you could draw a 30 gone and connect all the vertices.
Okay, and so what we're going to do now is we're going to talk about how could we mathematically find something like this instead of having to add 29 all the way down to 1. Okay, and so we're going to write formulas for that. Now that kind of sounds confusing, but I'm going to show you a really slick way that you can use on your homework. So let's look at this conversation between Stephanie and Aaron. Now this is taken from your book. It's on page 110. So you can kind of follow through the reasoning here. So let's start up here with Stephanie. She says in the diagram with 3 vertices, there are 2 segments from each vertex. Now when she says segments, she means this and this. That is 2 segments. Okay? So then Aaron says, if there are 2 segments from each of the 3 vertices, why isn't the rule 2 times 3 or 6 segments? Makes a good point. Stephanie says, because you are counting each segment twice. Okay, so the answer is really 3 times 2 divided by 2. So look at what happens. When she means counting it twice, you've got a red one here and a green one here. Those are the same segment. They're overlapping. Okay, so in the diagram with 4 vertices, there are 3 segments from each vertex. Right, but each segment got counted twice, so what do? Divide by 2. So really there are 4 times 3 or are divided by 2 or 6 segments. So with that in mind, that same thought, we're going to look at how you solve a problem. This says if you place 35 points on a piece of paper so that no 3 points are in a line, how many line segments are necessary to connect each point to all the others? Okay, so this is the same, these first 2 are the exact same thing that Stephanie and Aaron were talking about. I went ahead and threw in the 5th one. Okay, so the very first thing you need to do is we need to write down how many vertices will there be. So if I'm placing 35 points, how many vertices will there be? 35, right? Because that's basically how many dots there are. So that's the first question you need to ask yourself. How many vertices? And so that would be the same thing as how many people. How many people, right? Okay. So how many segments from each vertex? Well, let's look. When I had 4 vertices, I had how many segments? I had 3, right? When I had 3 vertices, I had how many segments? 2. When I have 5 vertices, let's see, 1, 2, 3, 4. So if I have 35 vertices, how many segments am I going to have from each vertex? 34. Now you're going to need to visually draw a diagram on each of these or look at the pictures in the book, because sometimes it won't always be one less. Okay? So our formula is the vertices times the number of segments divided by 2. That's what Stephanie and Aaron talked about. So in order to find how many, I would take 35 times 34 divided by 2. So what will that be? What? 595. Just for kicks, I want us to write this formula in general terms. So say, for example, if I had like 100 points or like 500 points, so I want to use this in terms of n. Okay? So when I do n, I'm going to liken the vertices to just n. That'll be my number of vertices. Okay? So in this case, what will I do if I have n vertices to find how many segments? N minus what? Good. So you're going to compare the two, 35 and 34. So really, I have n times n minus 1 divided by 2. So now using that formula, I could find it for 50, I could find it for 100, I could find it for 1,000 just by plugging those in. So this is the thought process you're going to need to go through to find each of your problems. Okay, you need vertices, segments, and then plug them in. Questions? You've only got 4 problems today. Okay, because this was actually number 5. I need you on page 112 to do 4. Now you need to pay attention to your diagrams. Pay attention to your diagrams, okay, when you go through and answer those questions.